given a sequence here, and we're also given that it does achieve an absolute maximum value. And we're asked to find out for how many terms of that sequence is it equal to the maximum value. Okay, so a couple of lemmas here, or I tell you what, let's talk about what just a term in the sequence, like for example, right here, f at 2, just to make sure I'm doing good notation for you guys, f at 2. You can think of this as f evaluated at 2. This is just the notation kind of reserved for sequences. This is equal to 15 squared over 2 factorial, which is just 225, okay, over 2. All righty, so you can see how quickly this thing grows. Just for comparison purposes, f at 1 is just equal to 15. 15 raised to the first over 1 factorial is 15 over 1, so we'll just write down 15 here. Now, so you can see at least the first 2 terms have an increasing pattern. All right. Now, the idea here is just to find out how far it increases, and then if it starts to decrease again, which we know it will based on the given information, that'll allow us to determine any maximum values. Now, this statement right here is hopefully fairly self-explanatory. These 2 statements are equivalent. If you multiply both sides of this inequality by f sub n plus 1, you get that f at n is greater than f at n plus 1. And that's equivalent to the whole sequence being decreasing, meaning the numbers to the left, starting from left to right, are bigger numbers than the numbers on the right. The example would be like 1 over n. You know, 1 over n, you have 1 over 1, 1 over 2, 1 over 3. That's definitely decreasing. And, I hope you like this notation. I've seen this before in real analysis books. This set means the entire sequence. Okay, so this entire, without writing it all out, this is just a clean notation here. Okay, now a similar argument tells you that f is decreasing when you have f at n less than f at n plus 1. Now notice we're not mentioning what the n plus 1s are. We're just assuming it's for all n in this definition. But the real goal is to find out the range of n's where this would happen and the range of n's where this would happen. And that goes fairly quickly, actually. Here's the algebra associated with, you take the ratio of 2 terms, and this is very similar to the ratio test, or same appearance as the ratio test in calculus. But notice here, if you invert and multiply, you just get this simple expression right here. If you invert and multiply, you would have n plus 1 factorial up here, and that'll leave n plus 1 when the n factorial parts cancel. Then laws of exponents give us this. Now, it's very clear that fn is decreasing when n is greater than 15, right? Because this would create a value greater than 1, right? If you put 15 right here, if you put 15 right there, you have 16 over 15. I'll just write it out to the side. For n equals to actually, I probably should say greater than, maybe greater than or equal to. This may be a slight mistake here as far as maybe I need greater than or equal to. But let's say that n was equal to 15. Okay, you get that this part right here would be equal to 16, right? I mean 16 over 15, excuse me, 16 over 15. Okay, so you see that's definitely greater than 1. That's greater than 1, which is this condition right here. And remember, these are discrete. It's not like there's intervals of numbers here. We're just going at discrete points, which makes this a little more confusing, I guess. But so anyway, so we get that f of n is increasing when n is, or that's this part right here, sorry. We get that f of n is decreasing when n is greater than equal to 15. And in a similar fashion, we get fn, the sequence is increasing when n is less than 14. Okay? And so if it's increasing to the left of 14 and to the right of 15, that implies the maximum value m that we designated right up here would have to, it would achieve its maximum value at 14. But what's a little sneaky about this? Is that, take a look at this piece right here. It turns out these two are equal. And you can tell that that happens when you put a 14 in here. If you put 14 in here, you get 1, right? That means that when you multiply, the f at 14 has to equal to f at 15. Okay. Now, but anyway, it's the verification. It's not so difficult. Two fractions are equal if and only if you cross multiply. So what you would end up with right here, when you cross multiply, you would end up with 15 factorial. 15 factorial times 15 to the 14th. Okay. And y'all, what I'll do here is I'll just put kind of a question mark above the equal sign because we're checking, really, right? Now you could subtract these from each other and you get 0 as well. That's another approach too. So what I did is I did 15 factorial times this, and I'm going to bring this guy up here that's cross multiplying, a condition for equality for fractions. So what you get here is 14 factorial times 15 to the 5th. 15 to the 15th, excuse me. All right. Now, so we're going, are those two things equal to each other? Well, notice right here, if you take a 15 out of here and put it here, this would become, okay, again, y'all, this 15 factorial means 1, 2, 3, all the way up to 15. So you can rewrite this as 15 times 14 factorial. Trying not to run out of room, folks. 14 factorial there. Okay, but again, the that would be, and this, let me just keep writing here. So that's 15 to the 14th, right? Probably showing more work than is necessary for you guys, but notice that when you do exponents here, you get 15 to the 15th, right? So this becomes 15 to the 15th, raised to the 15th power. Okay, times 14 factorial. So, just a little bit of algebraic manipulation, but notice that's exactly what this is equal to, right? I just wrote it backwards, but these two guys are equal to each other. So what's the answer to the equation? The answer is that we have two maximum values, okay? There's two maximum values. It happens for n equals to 14. N equals to 14 or 15. Sorry, that is horrible. That's supposed to be 14, 15 right there. Okay, so the answer to this question after all the talking is just 2. Let me write it over here. 2 is the answer. Okay, answer to question is 2 values. Those are the 2 maximum values. And hopefully that makes sense with respect to this increasing, decreasing stuff that I wrote down. So this is the answer right here. And again, another way to have verified this, would have been to just actually subtract these two from each other. And it's a nice little algebra exercise, I guess. Subtract these from each other and you will get 0. It's another verification process. Hope you enjoyed.